Before jumping into the subject, let me first introduce our partnership with Prometheia, because it is important for us to establish a good network of partners being able to deliver on our platform. And there are partners knowing and understanding the GRC space from a consultancy perspective, and this is why we choose Prometheia. But Prometheia is also strong, having developed in the artificial intelligence many of the algorithms and understanding how to apply this technology into data like the operational risk management. Now, we have been listening in the previous sessions how large is the amount of data and information that we are collecting into the GRC systems, starting from the controls that Kevin was pointing out this morning on Verizon, but here in this same room we were talking about regulatory change management and the volume of regulation that we need to undertake. So I think one aspect to get all this data working for us and extracting the value out of this data that we consistently have in our GRC system is an essential part of our evolution path. That's the reason why today we are talking about artificial intelligence applied to the supporting the GRC system and specifically on operational risk management. Now, Prometheia has a number of people dealing with these tough topics, algorithms in the artificial intelligence, and Michele Filannino is the principal data scientist in Prometheia. Not only, let me give some background on your experience, because in 2016 you were awarded of a PhD in computer science from the University of Manchester, so good experience here in UK. But you had also joined the Massachusetts Institute of Technology in US to establish additional research on the artificial intelligence space. And finally, in 2017, you were appointed as associate professor at the University of Albany in New York. Yep. So quite extended knowledge around these systems and these topics, and jointly with the partnership we are building with Prometheia, we think to provide our clients additional value. Prometheia is focusing mainly on financial sector, is a company well known in Italy due to the fact that all the credit risk models are mainly managed by Prometheia, but they are expanding also internationally. And due to this knowledge, we are creating a strong collaboration around central banks and other financial institutions where we expect to apply these models to their environments. I think, having said that, Michele, the stage is yours, the presentation
Thank
also.
You very much, Marco.
And thanks.
Thank you. Thank you for the kind introduction. Good afternoon, everybody. I'm a principal data scientist in Prometheia, and today I'd like to talk about the applications of artificial intelligence into the GRC realm, and in particular text analysis use cases that I'm going to showcase applied on the operational risk side. Now, before going into that, I would like to introduce the company. Prometheia was founded in 1974 as a spin-off of a research university group of economy, and since then has become one of the most important software development and econometric research consultancy company that we've got in Italy. We have more than 1,000 people working within our group and more than 500 clients. Now, in 2000, Prometheia also has a, let's say, very strong reputation about two particular solutions. The first one is in wealth and asset management, and the other one is in enterprise risk management. In 2018, we started a dedicated data science team, which I'm part of. And this team now counts more than 50 people scattered around Europe. And the goal of those people, me included, is to support our customers in their digital transformation journeys. Now, speaking about the digital transformation journey, we heard a lot today, this morning in particular, about the fact that the GRC is not an exception. There's a transformation journey going on, and it mainly goes around those points. In particular, as you know, things are becoming a little bit more proactive rather than reactive. We would like to be able to be in a position where we would like to predict risks and to foresee them in advance as much as we can. Also, it's always more and more important to understand that the nature of the risks that we are taking into account is interconnected. So using different lenses and different methodologies in order to tackle and analyze and measure those problems is actually not ideal. So the interconnection and dealing with interconnections and considering those interconnections within the analytical frameworks that we use is actually of paramount importance. And then there is also the problem or the trend related to data and analytics. Today, in particular this morning, we heard a lot about cloud infrastructure, high-performance computing, machine learning, artificial intelligence. And this is something that is going on, is happening. We believe that this process is an ongoing process, and in order for this process to end and end well, we think we need three ingredients. The first one is the hard specialized skills that we need in order to interpret and make sense of new business models, on new technologies, and in particular on new types of risks. Think about climate change related risks or even cyber risks, for example. On the other hand, there's also something related to the platforms and software solutions that we use, and in particular the fact that ideally we want them to be able to naturally and deeply consider and support advanced analytics techniques. And when I talk about advanced analytic techniques, in particular I'm referring to artificial intelligence, which is my field of expertise. Now, there are many definitions of artificial intelligence out there. Some of these are pretty, fancy and futuristic. The one that we like is to see at artificial intelligence as a new set of opportunities, tools, and techniques that can have a disruptive potential, and actually in lots of disciplines they already prove that. In particular because they allow us, in some cases, to tap from not only structured data, but also unstructured data. Now, if you're not familiar with the difference between structured and unstructured, I'm aware of the fact that it's a bit technical thing, but I'll try to give you an example so that we are on the same page. When we think about an entity like a bank customer, for example, and we think about a database that contains all the information about this customer, that is a structured piece of data. This means that at some point, someone that we typically call knowledge engineer or data engineer sit there and reason, put a little bit of thought on how many micro pieces of the information are there. So I'm going to have a field that is a name, surname, date of birth, and so on and so forth, telephone numbers, for example. Now, this is nice because this gives us a schema. A schema is necessary to make this information machine understandable. When we don't have a schema, we have a problem because we cannot plug any advanced analytic solution on top of it. So if you think about the example of the customer, for example, when we have those fields, we know what is the data type and we know what is the algebra that we can use on those data type. And algebra just means that we know what we can do with this type of data. So for example, everybody knows that a telephone number is made out of digits, but it doesn't make sense to multiply two telephone numbers together. And this is pretty easy to understand once we have a schema, even for the machine. Now, if you think about more complex types of data, like the one we deal all the time, things like CVs, reports, emails, images, videos, snapshots of articles, and things like that, PDFs, attachments, presentations like this one, and so on and so forth, they don't come in a schematic in a structured way. So a computer doesn't know what to do with that. And there's no way to make him understand that. The only thing that we can do is to use techniques that tend to structure the information, so to break this information into pieces that are machine understandable. Why is that important? Simply because, according to the last research, it's an estimate, but it goes with 60% of the corporate data that we store and we have in our database management systems are actually unstructured. And so this means that there's a huge source of information that we can tap from if we only know how to do that. And this is what we do for a living in Promethea. Now, I'm particularly interested in everything that contains text or can be somehow translated into text, or even speeches, records, and things like that. And text analysis, in fact, is the artificial intelligence technique that allows us to take all those data and pull out the concepts, the facts, and distill information and wisdom out of large quantities of those data. Now, if you look at a typical text analysis-based solution, you will always find 5 different components. Some of those have been already mentioned this morning, in particular the gathering component or step or phase, simply because this is one of the most crucial ones. Sometimes we want to assess what are the different data sources. We want to put those data together and recognize what are the schema that we can apply. At the same time, there's the structuring phase. The structuring phase means that we have to look at the data and see out of those CVs or out of those legal letters, what are the relevant bit of information that we want to take and we want to index, which means memorize those data in a database-like system so that those are immediately retrievable. Because they have to be used for advanced analytics, which we call here mining or visualization. I put an or there, it can be also an and, simply because visualization typically relies on the fact that at the end of it, there are human beings that are particularly suited to spot trends and patterns out of data that are visually represented, visually rich. And this is not easy to do, to convey some visual meaning, but we are going to look at some examples, pretty complex examples of those. And then there is also the mining part, which is starting from those pieces of information, we would like to process the information in a complex way so that new information can be created and can be exploited for the business processing we are targeting. In this particular case, you're going to see lots of applications on the operational risk side. Now, let's start. So the first thing that I would like to present to you is the unlucky case. The unlucky case for a text, for an artificial intelligence guy like me, is when we have to deal with data that are not digitalized. So we're talking about documents. There are lots of processes that we tackle and lots of customers that we serve that do present problems that are paper-based, literally. So we have to scan those documents and we have to somehow digitalize and then extract meaning out of it. Now, we worked with 2 large financial institutions in Italy on data that come from claims from people that are generated by a, let's say, misinterpretation of a national regulation about the calculations related to the premiums paid after treasury bonds. And the nice thing about, well, nice, quoted, the nice thing about these documents is that some of those don't even refer to amounts in euros. They are so old, they refer to lire, which is the Italian currency. And as you can see, they're pretty nasty because you've got some scribbles on the borders, and it's everything but easy for a computer to understand what is the content of those documents. On the other hand, we have a couple of examples of legal documents. Here, these financial institutions asked us to recognize what kind of document was handed, because these were coming from attachments through exchanges between different legals in this particular bank. And so there was a categorization step. A computer has to take into account this particular picture-like shape and then decide whether it is an appeal or it is just a letter or it is somebody that is actually claiming something. And then according to the type of according to the nature of those documents, we have to be able to extract particular pieces of information. Sometimes we are lucky, and lucky means that the text is already into a database management system. Now, I have to say that when I was in MIT, I used to work on clinical data, and the problem there is that even after the Obama administration, we had a major problem in getting data. Data were typically not there because they were not digitalized. In GRC, because of regulatory purposes and because of the way the business processes work, typically when we search for data, for example, like this one, event loss descriptions, we already have this kind of data. So this is already a good news for us. But the bad news comes immediately after, when our customers typically end to us 100 millions of those texts, and they want to know what are they talking about overall. So typically what we do during the assessment, this is a project that we did with probably the largest financial institutions that we have in Italy. We go into the information that they provide us, and typically we found some categorical information, like in the database there's written somewhere, very complicated to extract as a piece of information, but we can still do that. There's written that this particular event loss description is talking about input and or execution errors, operational management problems, and bank accounts. Now, if you think about the fact that this comes from a financial institution, it doesn't say a lot. So this means that an operational risk manager has to go through this particular text and read it and make sense of it. And then it has to repeat these 20 million times to have an overall understanding on what's going on, what are the macro trends, and how things are moving. What we did was to build a tagger. A tagger is a piece of software that automatically, like a human being would do, reads the text and extracts all the possible signals that are related to the business process. In this particular case, we are able to extract products and root causes. So what you can see here is a list that is more fine-grained. And so we're talking about still bank account, but also mortgage, also insurance policy on mortgage, unearned premium, misapplication of charges, misbehavior of bank staff. Now, it turns out that when me and Paolo showed this list to our reference, our operational risk manager, with this particular list, without going through the text, he already knew everything was in there, already knew the case, and he was totally familiar with it. Of course, we are not taking out, for example, names of people and other pieces of information. So sometimes they have to go back. But if you want to have an overall look of what are the trends, how things are moving according to the products that you're selling or the services that you're selling, you don't need that kind of information. You need those. Now, this is also nice because it allows us to give to the customer a structured representation of the text. This is an abstraction of that text. We're telling here that that text is a composition of those concepts. That's it. So starting from this kind of representation, we developed this solution. Now, we found semi-automatically 300 different business concepts in those data. What we did was to focus on just one. In this particular case, the disputed bank transfer. This is an original time series that you're seeing, a real one that you're seeing right here. And then we said, okay, we would like to count how many times that particular concept shows up in the records according to a particular date. And then we have a time series over there where we can see that there is a particular trend. Now, using automatic techniques, we can segment that time series in segments. Each one is different from an average perspective. You can see the line dotted on there. So we can generate with a template filling algorithm, we can generate a description that is telling us the number of events from April 2020 diminished on average of 2.1 events per week as opposed to the previous time period. So we can understand analytically that there's a downward trend in problems related to disputed bank transfers. Now, since we started playing, we wanted to see whether there were any correlation between this specific phenomenon that can now we trace overall and all the other 299. And so we computed the so-called co-trends. So in other words, we are asking the machine, now that you show me this particular trend, is there any other thing that trends positively or extremely negatively with respect to that particular trend? So is there another process or another problem or another product that behaves accordingly? And apparently, for example, we found that the disputed bank transfers were positively correlated with e-commerce revenues and a specific kind of cyber attack, because among those concepts we also had cyber risk-related problems, swap SIM, but there was a negative correlation with the man-in-the-browser attack. That's still another kind of techniques that they use in order to hack systems. Now, we are not saying by any means, any stretch of the imagination that these would suffice to make a coherent narrative. But what we are saying is we can produce automatically linguistic trends and reports that are quantified in order to support the understanding of large volumes of data. Another thing that we can do is to explore better the connections between the different concepts. So here you have a graph representation where each node is one of the 300 concepts that we've seen before, and the strength of each connection depends on how likely it is to find those two problems together in the very same event loss description. And so as you can see, there are some clusters, and those will correspond to a particular phenomenon that co-occur together very, very often. Now, from an overall perspective, you can also see better the clusters, and I can tell that this is, for example, the mortgage-related cluster. There is the credit card cluster, the ATM cluster. There is another one over there, the insurance policy, and then the insurance policy will be close to the mortgage cluster, and so on and so forth. This gives us the possibility to pinpoint even odd correlations that for the operational risk manager are actually not so expected, let's say. And so narrow down, filter down those 20 million records in 5 cases that are odd for him, and then further investigate them. There is also an aspect that we always find to our customers, which is the data quality side. This morning, several people were discussing about the quality of the data and the quality of the data and how that impacts the algorithms. What we have here is actually a system that, starting from the description of a loss, learns from those records the mapping between that description and the event type. Now, if you're not familiar with the event type, it's just a label that comes from a regulatory taxonomy. And what we did was to learn and train a machine learning classifier that goes through that particular description. It reads it and says, I guess that the correct event type in this particular case would be 412. And then we compare the predicted one with the with the one that we have in the database in the bank. And so when we have this situation, we have an agreement, there's nothing we have to do. But when there is a disagreement, so in other words, our algorithms predict an event type that is totally different, then we have potentially a problem. So we use confidence-rated classifiers that not only gives us a prediction, but also give us the level of confidence for that particular prediction, so that we have a way of ranking the most confident disagreements and then ask the operational risk manager to check them out. Now, we deployed this solution in many, many different financial institutions. And we found that in some cases, according to how clean the data were at the beginning, we found that in some cases 90% of our predictions were actually spotting mistakes, human mistakes. It can always happen. And in many of those 90%, in many cases, the predicted automatically predicted event type was actually the one that was picked by the operational risk manager to be the most pertinent one. So in other words, this means that when we have lots of data, artificial intelligence solutions can actually help in doing these kind of tasks. Now, why is it that we are talking about these things today and not 5 years ago? So in the community, and in particular the natural language processing community, there's been a revolution going on in the last years. And in particular, it's about a thing called large language model. Now, I'm not going into the fact that it's a complex algebraic space where concepts lie in clusters of similar meaning. It would suffice to say that what you are seeing here is just a 3D representation of an actually 100-dimensional representation. Each point is a specific concept that has been retrieved, automatically recognized from those records. So here you have things like fraud, or everything is in there, linguistically speaking. Now, in those epochs of evolution, the algorithm learns how to rearrange those points so that the close ones are actually synonyms or are used interchangeably in the language. This means that when an operational risk manager wants to get all the data that are actually talking about climate change, he can query for climate change, but then we can expand according to the neighboring concepts. And so we can find other concepts too. Closing, the point here is that I hope I persuaded you into thinking that there's a lot that text analysis solutions can do for us. And I'm really, we're really looking forward to do more of these and the integrations in the GRC community and into GRC solutions. As a company, we are committed to provide this level of sophistication to our customers and partner. So thank you very much for your attention.
Fascinating work. Are there any questions? Because it's a fascinating, evolving world, so I think many of us are thinking how to apply these techniques. Any question from the audience? Yes, please.
How long does it take to teach a machine to recognize the patterns correctly?
It's actually very, very fast. If you think about, I don't know, something like to 20 millions of records, we're talking about minutes.
And do you apply these techniques also to other areas? Because you today you cover the text analytics, no? But are there other?
So those techniques are specific about text. So we do apply them where we have text-related problems, and we have many text-related problems aside from the operational risk, but they tend to work pretty well on text.
And I understand you realize real cases, no, with clients
absolutely,
across
and
different.
Absolutely, and we have lots of anecdotes about the fact that you have to carefully train per bank, per language, that particular models. Otherwise, you will incur in some problems. Even though the operational risk language is not the generic Italian or generic English, you still have some nuances that are peculiar for each financial institution. So you want to start from a generic model, but then adapt each model to a specific bank because different people have different writing styles.
Excellent. Any other question? Right in time? No? Oh, one question. Sorry.
No, I was just going to ask the question that, some of the use cases that you highlighted around monitoring and are the standard use cases that I think. Have you done anything in terms of predictive risk insights in the predictive space?
Not yet, because the nature of the data that you would require in order to have a overall picture and so establish a prediction base that is actually efficient would be prohibitive for the moment. Those techniques are very, very good when you have a closed, defined dictionary or language. In that case, if you do consider a multitude of documents and PDFs and notes and things like that, it would require a huge effort. So far, we didn't have a chance to work on that, but I would look forward to it. Thank you.
Any final questions?
I'm just going to just more in terms of understanding sort of the technology in terms of driving some of those insights. Is that more sort of, skills based in terms of Python?
Oh, well, yeah. So from a development perspective, we tend to use Python for as a programming language. And then in terms of models, all the techniques that you've seen are deep learning based, like the language models, in particular the large ones that we do synthesize, are actually based on algorithms that are neural network based. I don't know whether that answers your...
Yeah, no, it does. I think
Okay.
We'll have deeper conversations.
Oh, okay, yeah, definitely. Yeah, okay.
Excellent. Thank you,
Right.
Michele.
Thank you
Thank
so
you.
much, both
Thank
of
you.
you.
Fascinating.